Kia ora koutou. Ko Andy Costello taku ingoa no te tarawhiti aho. Kei Aratu Forest aho I mahi ana. Ko aho te Estate Planning Manager. Thanks to University for having us here today. Really quick introduction to Aratu Forest as it relates to this talk. We are building 28 k's of new road every year into first rotation forests in some really challenging country on the east coast where we're subject to our fair share of rain events. Our road design and road building practices have evolved a heap over the last 6 or 7 years. Key to our success there has been road design with road eng. The amount of storms we get means that we're able to regularly check what works and what doesn't. What we're going to talk about today, firstly, why design? Secondly, the information you want to have at hand before you start designing, communicating your design effectively to your supervisors and your contractors, and then some things you can do if you start combining LiDAR data with drone data. So, why would you design? Here's a really good example we built maybe 5 or 6 years ago now. We found in tricky country like this, when it's vegetated, you can't always see all the options or all the features. While it's important to stomp the hills, we found it really useful that before we stomped, we brought the LiDAR data into the terrain module, built it, and started flying around to see what the options might be. And also to the second point there, testing the alignments to see what's going to work in the computer. Last thing you want to do is start shifting dirt in a tricky situation, then find out once you're halfway through that the road grade isn't going to work. In this case, we had a control point at the bottom here with this bridge, which we had to put in for this road. We could have made it higher, but it was going to cost an extra couple $100,000 for a full bridge rather than this submersible one. We had another control point up the top where this new road met an existing road on a bluff above a Kakabeak. This is also in the middle of a PMA, Fancy Native, and we're constrained on 3 sides by a river. We're also straight across the river here into End Hall. The whole way up, we're on max grade. This corner here is minimum radius. There's a lot of things here that could have tripped us up. So for a build like this in particular, it's really important to us to be able to test in the computer that the alignment will work, so we don't spend a bunch of money, get halfway up and realize it's going to be a road that's going to give us issues for years come. To get the most benefit out of the design, you want to effectively communicate it to your crews. That lets them plan ahead. If they don't have that information, then they might not realise that they're coming into a section which is going to need to be end-hauled. If they don't realise that, they might not have had a chance to identify an appropriate dump site to put all the dirt, or they might have one but it's not big enough, or it's not stripped, or they don't have the right gear on site. They might not have the moxies and the pad foots and the whatever your preference is to manage the tip head. And if they don't stop, they'll end up in a situation where they might start overfilling the benches, or the fill batters might get a bit steep, and you'll end up with a road that's less stable than you would have if they had the ability to plan a bit further ahead. I think that's maybe been one of the bigger changes we've had in the last 5 or 7 years. It's been really beneficial. This road here we're really stoked with. It's been in place for many years now, weathered many storms. The road's 100% built on fill here, so we've got a big chunk of fill in fairly close proximity to a river, and it's been really stable. So, being able to maintain that fill slope and knowing it's going to be compacted right and everything, it's been awesome. We've also been able to keep real clean margins between the road prism and the native. What I mean there is that because the supervisor and the contractor knew where the road was going to stop, they didn't clear any more native than they had to, which is awesome when you're operating in the middle of a PMA. So we're happy with that. Okay, next up is information you're going to want to have on hand before you start designing. Truck configuration. What sort of trucks are you designing for? I won't go into too much detail here. I've left the numbers in the slides in case anyone wants to review them later, but if you do, please consider that they're just regional estimates. They're a bit of a ballpark that can work as a target for us. They're not, it's not a black and white thing. Regionally specific to me on the East Coast means that we've got a slippery surface because it's likely to get a bit contaminated with the heavy clay. It's built out of poor quality metal because that's all we've got available. We've got a range of drivers and we want roads that are going to be safe so they can all drive and train on them, rather than just building a road that's good enough that only the pros can use it. We want to be able to operate year round, and we've got a fleet of Kenworths with CTI and cross locks and diff locks and power dividers. Different trucks, different drivers, different regions, different surface, different conditions. It's all going to impact the grades that you're going to be able to achieve. The key factors that impact what we can do in terms of maximum grades are the weight distribution, so specifically how much good weight you have on the truck, increasing the traction on your drives and your steers, versus the bad weight on the trailer, which is fighting you as you're trying to drag it up the hill and trying to pull you offline as you're trying to get round a corner. Also, the number of axles has a big impact. Every extra axle is more rolling resistance. So just to run through them really quickly at a high level, from worst to best, an Aussie B double, it's got no extra traction up the front, but it's got 6 axles behind it and a whole lot of weight. Being a couple of semi-trailers, it's also connected high on the truck, which as the truck's going uphill round a corner, gives the trailers more leverage to try and take the weight off the outside drive tire. If it goes if it goes light, it loses traction. So that doesn't help. Next worst we're dealt with is these stem trucks. Look beautiful, love them, but they're a challenge to build roads for. Main reason being that it's actually the logs that drag the trailer up the hill rather than the drawbar. This drawbar slides to allow it to go around corners. All it's really there for is to steer the trailer. To allow the logs to drag the trailer up the hill, they've got to be twitched down really tight. That effectively makes the whole truck and trailer unit combined very rigid. It can't pivot in the center to allow for camber, which means you have to build your roads flat, which impacts their ability to go around steep corners. So you need to back off your grades a little bit for these things. The multis with the pivot in the middle don't have that issue. You can start introducing a bit of negative camber so that the trailer, rather than trying to pull the drives off the ground on the outside, actually pulls the back of the truck down on to the pavement, increasing the traction. So they work noticeably better than the stems rigs. Even better than a 5-axle multi is a 4-axle multi. You've got the same traction up front, but less weight and less rolling resistance at the back with one less axle. Obviously less tear too, but it can save you a little bit in road construction. Excuse me. I won't dwell on the older trucks, but they had bigger wheels, which also means less rolling resistance. Why these considerations are important to us is that a lot of our forests were built with these trucks in mind, and as we come into the second harvest of them in a few years' time, we've got roads that probably aren't going to work for modern trucks, so we either need to reconsider our trucking fleet or rebuild some roads. I won't dwell on the specialty trucks. We've got a bunch of these 6x8s in our fleet and we love them. They're awesome. Cost a little bit more, but usually cost less to run than the road we would have had to build otherwise. They do suffer a bit when the pavement's contaminated with that heavy clay like it is here. Without traction, they don't do so good. Also, these ones here, you still need to understand how steep they can go and what sort of room they need and what corners they can go around so you can build an appropriate road. I won't get into that in detail, except just to say that with these and the 6x8s, as well as designing the road, you also want to consider a bit more how it's going to be built. Consider how you're going to spread metal on a 20% grade. It certainly can be done. There's ways to do it. You just want to make sure you know how you're going to do it before you go ahead with the design. Next up is having a clear idea of what sort of road you want to build. How wide's it going to be? What do you want your cut batter and fill batter to be? How big do you want your ditch to be? All those sorts of things. The blue line here is the default that comes from RoadEng, and be absolutely fine in a bunch of situations. For us though, with our poor geology, that fill batter there is too steep. We try to limit ours, I think I said before, to 30 degrees. If we built fill batters this steep, the road wouldn't be resilient in a storm. Also, shifting dirt for us is really expensive. We don't need the extra width here, so we build them a bit narrower. They're still safe, but we don't have the extra environmental impact and cost of a wider road. A whole bunch of other things to consider with road geometry. All of these things will impact how steep you can go. I'm not going to cover them all today. We don't have enough time. I'll leave them up there in case people want to review the slides later. The comment I will make is that if the road's going to be tricky for any of these reasons, then trying to make it consistently tricky. Trucks get stuck on pinches. If you don't have pinches, there's a better chance of the truck getting out, even if it is consistently tricky. Okay, you've gone to the effort of making a good design. You want to get the maximum benefit out of it by communicating it effectively to your contractor and crew, as we discussed earlier. What's worked for us is exporting a georeferenced PDF that looks like the image at the bottom there, directly out of RoadEng into a Dropbox, which the contractors and supervisors then access, and they will bring that image into a free app called Avenza Maps on their phone or iPad, which then uses the phone's GPS to put a little blue dot at their location. It's got a LiDAR hillshade background with 1 meter LiDAR contours. Red line's the center line, obviously. The red labels tell them what grade we're expecting and where the grade is going to change. The green line is arguably the most useful output in RoadEng language. It's the earthworks extent. It tells the road line crew that they're going to have to remove at least this many trees, and it tells the road builders that they want to put their toe bench and start building their fill batter on this green line as well. If they do that, then we should be golden. The black labels tell them how much cut or fill at each location, and a nice legend up here to show them how that's measured. It's on the center line rather than the cut batter, and it's from where the original ground was rather than where the ground is now that they've stripped all the topsoil off, which for us, it can be a couple of meters in places, so it's an important distinction. We also try and show them dump sites where we find good locations so that they can plan ahead, as we discussed before. We've found that in most cases, the phone's GPS is fine. If we've got some particular values we're trying to maintain, or it's a particularly tricky section of road, we've got a Bluetooth GPS receiver, which pairs to the phone and brings the accuracy right down to 0.5 meter under canopy, so we can start banging in stakes, and it works really well. We also go to pains to communicate effectively our crossing designs. Key one is the pipe length. Anyone that's designed crossings will know it's pretty hard to estimate what the pipe length is going to be in a situation like this, where you're going around a corner, so you've widened the road and the pipe's not at right angles to the road. You're trying to maintain berms and fill slopes and everything. It can get a bit hard to eyeball. And if you eyeball it wrong and you're ordering in big pipes specially and you get it wrong, you can end up in a situation like this, which isn't our forest. I might like to make that distinction up front. But all the grass seed and sediment fence in the world isn't going to stop this being a hassle for a long time as the oversteep fill slope collapses into the creek. I suspect this will have to be rebuilt one day fairly soon. This is what we aim to achieve. This is one of ours. We're quite proud of it. We went to the extent of GPSing this mature tree, bringing that GPS location into the design and bending the road around it. You see again, we've kept really clear margins with the native. We haven't stripped any more native than we needed to. We've maintained our 30-degree fill batter, and we've maintained drainage across the crossing down the road, rather than having the low point above the pipe where the water's going to pool and cause sedimentation in the creek. We've got good separation. You know, this fill isn't going to migrate, and we've got our mate here checking out our fish passage, and he was real happy about it. Still to be finished with metal and grass seed, but really that's just lipstick if you've got the underlying formation right. So we're happy with that. We also communicate our skids. We do this with the high resolution GPS. The green line again is the earthworks extent. Again, for the road line crews, you've got to take at least this many trees off, got to clear this area. And then for the road builders, put your tow bench here. The purple line is out of road edge. That's where the cut turns into fill. And when we mark that on the hill, it's effectively the elevation of the finished skid level. So if they start with the tow bench on the green line and start building up at 30 degrees and stop when they get to that level, we'll end up with a skid that's the right size and shape with all the fill taken care of nicely. So that works well too. Also, just making pretty pictures to communicate ideas to stakeholders. This is post-Gabrielle. We were contracted back to the local authority to come up with a solution which ended up being a couple of K bypass for a local road where a bluff collapsed involving two 70-metre bridges, I think it worked out. So they invited us in to help communicate to the landowner whose farm we're going to build the road through, what it was going to look like. So we're able to build a couple of houses to show them where his sheds and houses were going to be, show him where his existing tracks were, show that we're going to build a berm to reduce the road noise a bit. And you can even go to the extent of pulling in bridges. Road End are really supportive if you're trying to do this sort of thing. They helped us out no end. It was awesome. Combining LiDAR data and drone data is something we do quite a bit in the forest, as well as when we're working on these storm projects. In this example, the river had taken out the old fill below the council road, and they asked us to investigate what would be involved in shifting it over. So we knew where the road used to be and the surrounding ground was from the LiDAR data. We went and hit the slips with the drone, brought them into the terrain model. You can see we've got the smoother LiDAR data here, and circled in red is where we've brought in the drone data. Merge them together, and then you've got a terrain where you can start building a road and say with confidence that yes, it can be done, but you're going to have really big steep cut batters, and you're looking at 50,000 cubes. So they were really stoked with how quickly we're able to turn around this sort of thing and help them optioneer, I think is the term they use, trying to figure out what to do with some of the storm damaged infrastructure. Here's another example here. So this used to be a 2-lane tar sealed road, and just to help visualize how much material had gone missing, we ran a profile through here looking at what the road used to look like. So from the LiDAR, we can tell that the road used to look like this black line here, and what it looks like now from the drone was the red line with that exposed sheet pile being there. So we could help them visualize that you didn't just lose the dirt on the other side of the sheet pile, you also lost all your riprap and the retaining wall as well, just to help visualize what was going to be involved if they decided to try and rebuild that section of road. All right. I hope that was useful and look forward to taking any questions in Zoom. Thank you.